Hi, so we continue our lecture. Okay, since we know that the three-phase voltage are 120 degree out of phase with each other, so there are two possible combination of we call as a phase sequence. Okay, one possibility is shown as this figure. Okay, and in this figure we express mathematically as VAN equals to V peak with 0 degree. VBN is equals to V peak with minus 120 degree, and VCN is equals to V peak with plus 120 degree or equal to minus 240 degree. Okay, so as we see here, this is VAN as a reference in 0 degree. Okay, so each voltage, okay, there is a phase difference. The phase difference is 120 degree out of phase. Okay, for each voltage. Okay, that's why for each voltage we call it as a phase sequence. With 120 degree out of phase. This is one possible combination. Okay, the second combination is VAN, okay, with 0 reference, 0 degree reference. VBN, okay, located at V peak minus 120 degree, and VCN equals to V peak plus 120 degree. So the difference between the previous combination is the the angle for VBN and VCN. So the VAN, VBN, and VCN as a phase sequence in positive phase sequence. Okay, let me discuss about the positive phase sequence. We call it as a ABC sequence. Okay, positive sequence we call it as ABC sequence. Okay, why we call it as ABC? Because as the phasor rotates, it follows the sequence as ABC or BCA or CAB. Okay, so the sequence produced when rotor rotates as a counter clockwise. Okay, so VAN will lead VBN. Okay, VAN will lead VBN. Okay, Wheatstone leads VCN. Okay, this is a positive sequence ABC where the sequence rotate as A, B, C, then turn to A. For a negative phase sequence, okay, we call it as ACB sequence. Okay, we notice that the ACB sequence, okay, the angle is switched with ABC sequence. Okay, so as a negative phase sequence, the phasor rotates and follows the sequence as A, okay, A, then goes to C, then goes to B and rotates back to A. Okay, so the sequence produced when motor rotates clockwise. Okay, so from this figure, VAN leads VCN, okay, and which in turn leads VBN. Okay, this animation, okay, will show you how to determine the sequence using phasor diagram. Okay, let me start with this sequence. Okay, as you can see, as the rotor rotates, this sequence is called as A, okay, then B, then C sequence. Okay, this is called as an ABC sequence or a positive sequence. Okay, while this figure, okay, you see that it's 1, 2, 3, so it rotates as 1, 3, 2 sequence. Okay, so this is a negative sequence. Okay, you can convert 1, 2, 3 as A, B, C. As 1 is A, 3 is C, and 2 is B. To make you clear the definition of phase sequence, okay, let me do this example. So this example want to determine the phase sequence to get to the set of this voltage. Okay, so determine the phase sequence is we want to know either this set of voltage have a ABC sequence or positive and or negative sequence or ACB sequence. Okay, so for this set of voltage, first thing that we have to do is to convert the time domain voltage to phasor domain. Okay, or phasor form. Okay, in phasor form. So VAN will be 200 with 10 degree volt, VBN 200 with minus 230 degree volt, and VCN 200 with minus 110 degree volt. Okay, then what you can do is to draw a line. Okay, draw a phasor diagram. Okay, so that you can see the location of VBN, VAN, and VCN in terms of this angle. Okay, the angle number 1 VAN is 10 degree. Okay, VAN should label as VAN. The second one is VBN minus 230. So 200 minus 230, we set 0 reference here. So this is 0, minus 90 degree, minus 180 degree, minus 270 degree. Okay, 200, negative 200 degree is located around here. Okay, this is VBN. And for VCN, minus 110 is approximately here. VCN. So, one thing that I want to mention is each voltage is 120 degree out of phase. Okay. Okay. So what we want to know, either it is a negative sequence or a positive sequence. So you rotate this phasor diagram as in a counterclockwise. So you can see that from here VAN will meet VCN, then VCN will meet VBN, and then VBN will meet turn to VAN. So you can do a conclusion that this is as a C B sequence or we call as a negative sequence. Okay, we continue with the same method. Okay, but with different angle of voltage. Okay, so you convert this the time domain voltage to a phasor form. So VAN equals to 200 with 10 degree volt, VBN 200 with minus 110 degree volt, and VCN 200 with plus 130 volt. Then you draw a phasor diagram as a previous example. Okay, so the first one VAN with 10 degree, VAN. Okay, then VBN minus 110 degree, VBN. And VCN is plus 130. sorry, it's around here, BCN. Okay, so you can notice each voltage is 120 degree out of phase. Okay, so we want to know the phase sequence of this set of voltages. So you can see that VAN turns to VBN and VBN turns to VCN and then VCN turn back to BN. So from this figure, you can do a conclusion that this phase sequence is an ABC sequence, or we call it as a positive sequence. Okay, we move to another example. Given that VBN equals to 110 with 30 degree angle, determine VAN and VCN. Assume a negative sequence. Since it mentioned as a negative sequence is an ACB sequence. Okay, we know in ACB sequence, VAN equals to V peak with 0 degree, VBN V peak with plus 100 degree, and VCN is equals to V peak with angle minus 120 degree. Okay, so since VBN is 30 degree, okay, we know that VBN with 110 and 30 degree volt. Okay, so the difference between the angle difference between B and A is plus 120. Okay, so and difference between B and C is also 120 degree. Okay, we can draw a phasor diagram first. Okay, we put VBN. Okay, so we imagine that this rotor rotates as sequence A, C, B. Okay, after B, we move to A again, and C and B. Okay, A, C, B. Okay, so this is 30 degree. Okay, so the difference is 120. So 120 minus 30 degree is 120 minus 30 degree is 90 degree. Okay, so the location of VAN, okay, the location of VAN is here. Okay, this is VAN. Okay, so how to determine the angle for VAN? So you can put this reference as a 0 degree. Okay, so from 0 to VAN, okay, the angle is 90 degree. Okay, or minus 90 degree. So VAN is 110 with minus 90 degree volt. Okay, then VAN between VCN is another 120. So from here, okay, starting from VAN, so this is 90 degree. Okay, plus another 30 degree. Somewhere here. VCN. Okay. So to determine the angle for VCN, okay, you need to know that this value for another angle. Okay, so you know that this one is different as out of phase 120 degree, and this one is 90 degree. Okay, so the balance is 30 degree. Okay, so to determine the angle for VCN, we have to um, take the reference as in a 0 degree. So from 0 to here, okay, so 180 minus 30 degree is 150 degree volt. Okay, so that's how you determine the angle for VAN and VCN. So by draw a phasor diagram. Okay, so next example for an ACB sequence, VCN is 100 minus 140 degree volt. Okay, determine the phase voltage for VAN and BBN. Sketch the phasor diagram for all phase voltage and then repeat the equation for ABC sequence. So we do with ACB sequence first. Okay, we start with ACB sequence first with VCN negative 140 degree volt. Okay, so first you draw the phasor diagram. Okay, so the angle for VCN is minus 140. Okay, it's located here. VCN. Okay, so this one is minus 140 degree. Okay, so you know that ABC sequence, so rotate A, C, B, A, C, B, A, C, B. Okay, first we found VCN, then turns to BBN. Okay, so BBN, you know that this balance have another 40 degree. Okay, we start from this line. Okay, this VCN line. Okay, we plus 120. No, we have to all the difference between VCN and BBN is 120 degree. Okay, 120 minus 40 is 80 degree. So 80 degree is somewhere here. Okay, this is B, N. Okay, so we know that this value is 80 degree, but we don't know the angle for BBN yet. Okay, so the balance for this angle, okay, in between here is 10 degree. Okay, so as I mentioned, the reference for any angle, you have to start with 0 degree. So angle for VBN from 0 to here, okay, from 0 to here is 100 degree because this one is 90 degree. 90 degree plus 10 is 100. So VBN is equals to 100 volt with 100 degree. Okay. Then we have to find VAN, okay, where the difference between B and A is also 120. So you know this one is 100, so you have to add another 20 degree. Okay, so the 20 degree is somewhere here. B, A, N. Okay, so as you add this angle 20 degree, so this one is minus 20 degree. Okay, so from reference 0, okay, the angle for VAN is equals to 100 with minus 20 degree volt. or you can use in positive angle, okay, which is 340 degree. Okay, this one is for ACB sequence.